Usually when you install like a high-tech security system in your home, you expect it to verify everyone who walks up to the front door.
Right, obviously.
But imagine if that system was programmed to just automatically unlock the deadbolt for anyone holding a clipboard.
Just because they look the part.
Exactly. The system just assumes, hey, they look like a delivery driver, so they must be safe. And, that unquestioning automatic assumption, that's what we call implicit trust.
Yeah, and it is a massive problem right now.
It really is. It is quietly tearing apart the foundation of the modern internet. So, welcome to the deep dive. Here on Cyber Mornings Daily, our mission today is to give you a targeted, high-value cybersecurity briefing on the hidden dangers of this implicit trust in our modern tech stacks.
Because we're seeing this everywhere, right?
Absolutely everywhere. We're going to be looking at how the very systems designed to make life frictionless from AI coding assistants to open-source supply chains and even massive web hosting infrastructures, how all of these are actively being weaponized.
It's a critical shift in the threat landscape. I mean, we're not just looking at isolated bugs today. We are looking at systemic, structural flaws in how development tools inherently trust each other without asking any questions.
Yeah, the trust is just baked in. And we've pulled together 3 critical, freshly released security reports for you to really illustrate this.
And they are pretty alarming reports.
They really are. First, we have a maximum severity vulnerability in Google's Gemini CLI. Second, there's this massive credential stealing supply chain attack that just hit SAP-related NPM packages.
It's just wild.
Yeah, and finally, a 0-day exploitation of cPanel that essentially just removed the front doors from servers all across the globe.
Just took them right off the hinges.
Right. And I want to be clear with you listening right now, even if you aren't, a developer writing code or a sysadmin managing a massive server rack, the platforms holding your personal data, your company's data, your financial records, they rely on these exact tools.
Yeah, you are downstream from all of this.
Exactly. So understanding these attacks is really crucial to understanding how the foundation of the internet you use every day is currently under fire. Okay, let's unpack this. We'll start with the AI developer blind spot.
And we really do have to start with that CVSS 10.0 rating on the Google Gemini CLI vulnerability.
Because a 10 out of 10, that score is not handed out lightly.
No, not at all. A 10 out of 10 means the flaw is network exploitable, it requires low complexity, it requires 0 privileges, and worst of all, it results in total compromise.
Wow, total compromise.
Yeah. Specifically, Novi Security reported on this in the @Google/Gemini CLI NPM package and its corresponding GitHub Actions workflow.
Okay, so before we get into the actual mechanics of a 10 out of 10 compromise, let's break down where this tool actually lives. Because Google admitted that the impact is tied to workflows using the Gemini CLI in what's called headless mode.
Right, which typically happens in CI/CD environments.
Exactly. So for anyone who isn't living in GitHub every single day, what does that actually look like in practice?
Well, think of a CI/CD, so that's continuous integration and continuous deployment. Think of it as like the automated assembly line for software.
Okay.
When a developer writes code and submits a pull request, they don't manually test every single little integration. Instead, these headless bots, these automated systems that run without a human interface, they spin up, pull the new code, review it, build it, and test it.
So they're doing all the heavy lifting in the background.
Exactly. And the Gemini CLI was being used as an AI reviewer in this assembly line. But the fatal flaw was that, well, in previous versions, this tool automatically trusted the workspace folders it was reviewing to load its own configurations and environment variables.
Oh, man. So it's essentially that smart door we talked about in the intro.
Yes, exactly.
It's like giving a house sitter the keys to your home, and their instruction manual basically says, automatically trust anyone who walks through the front door wearing a fake name tag.
Right. They don't check ID at all.
They just execute whatever command the visitor hands them.
And what's fascinating here is how attackers are weaponizing that exact behavior to turn these automated assembly lines into direct supply chain attack paths.
Because the tool isn't questioning anything.
Exactly. Because the tool automatically trusts the current workspace folder. It loads any AI agent configuration it finds in there without any review, without sandboxing, or, any explicit user consent.
So an attacker just submits what looks like an innocent pull request.
Right. But alongside the code, they plant a specially crafted malicious environment variable, and they hide it inside a local .gemini directory.
Wait, hold on. So before the AI agent sandbox even initializes to review the code, it reads that local directory and executes the malicious variable.
Yep.
So the agent is compromised before it even wakes up to do its job.
Precisely. It's game over before the review even starts. The environment variable triggers command execution directly on the host system.
That is terrifying. So how did Google fix it?
Well, Google has had to address this by fundamentally changing how that trust is established. Now, users actually have to explicitly set a new environment variable. It's Gemini Trust Workspace, set to true if they're running workflows on trusted inputs.
Okay, so making it an active choice rather than a default.
Exactly. And if they are dealing with untrusted inputs, like, say, public pull requests, they have to completely harden the workflow. Oh, and Google is also really cracking down on the CLI's -- YOLO mode.
-- YOLO, which is a very telling name for a developer feature.
It really is.
I assume YOLO mode was designed to just bypass safety checks for the sake of speed.
Yeah, it fits the acronym perfectly. You only live once, so let's just push it to production.
Right.
Previously, this auto-approve mode would ignore tool allow lists and just run all tool calls automatically. And I mean all of them, including show commands, without any user confirmation.
Which is just asking for trouble.
Oh, absolutely. So now the policy engine actually evaluates allow lists even when you're in YOLO mode, just to prevent remote code execution via prompt injection.
Well, that's good at least. But the Gemini CLI isn't the only AI tool getting hijacked by hidden files right now, because security researchers also just flagged a massive vulnerability in Cursor.
Ah, yes, the AI-powered development environment.
Right. And if you're listening, want to look it up later, it's tracked as CVE 2026-26268. But all you really need to know right now is the severity score, which is 8.1 out of 10.
Which is a critical sandbox escape.
Yeah. How did this one slip through?
Well, the Novi security disclosure actually coincided with this flaw in Cursor prior to version 2.5. Cursor released an alert describing it as a sandbox escape through .git configurations.
Okay.
Essentially, a rogue AI agent can set up what's called an embedded bear repository, and inside that repository, it hides a malicious Git hook.
Okay, I need you to translate that a bit for us. What exactly is a bear repository, and what is a Git hook doing in this context?
Sure, so a Git hook is basically an automated script. It fires when a specific action occurs in your code repository.
Like when you save or commit code.
Exactly. And a bear repository is a version of your project that doesn't contain a working directory. It's mostly used for sharing code, but it still executes those hidden hook scripts.
Got it.
So in this case, the attacker uses a post-checkout hook. This is a script programmed to fire silently and automatically the very moment code is checked out. It requires absolutely zero user interaction.
Wait, I need to stop you there. So a user just asks an innocent prompt like, explain the code base, and that alone triggers a silent attack.
Basically.
How does asking a question run a hidden script?
Well, Asaf Lefkovich, he's the security researcher who analyzed this, he explained the root cause beautifully, and it goes right back to what we were saying about implicit trust.
Yeah.
It's not actually a flaw in Cursor's core product logic. It's a consequence of how standard Git features interact when an AI agent starts autonomously executing operations inside a repository.
Oh, I see.
Yeah. Levkovich pointed out that when the AI agent runs a git checkout command to fulfill the user's request, it isn't doing anything the user didn't implicitly authorize.
Right. The user told the AI to analyze the code, and the AI says, okay, well, I need to check out the files to read them.
Exactly. But neither the user nor the AI agent has visibility into what the repository's hidden rules have set in motion.
That is such a huge blind spot.
It really is. The AI parses a malicious file, usually called agents.md, that instructs it to navigate to this embedded bear repository and perform a checkout.
And boom, the trap snaps shut.
Right. That action silently triggers the malicious pre-commit hook. It executes entirely outside the agent's reasoning chain and completely outside your field of view.
Wow.
And if that wasn't enough, LayerX also discovered a separate unpatched vulnerability dubbed cursor jacking, which has a CVSS of 8.2.
Let me guess. Is this another assumption of safety just because a file happens to be local?
You nailed it. Cursor doesn't enforce strict access control boundaries between its installed extensions and a local SQLite database.
And let me guess, that database stores some pretty important stuff.
Just highly sensitive API keys and session tokens.
Of course. Meaning, any rogue extension you install locally can just reach into that database, steal your API keys, and pivot right into your backend services.
Yep, data theft, financial loss from API usage, complete account takeover.
And the underlying assumption is just that because the extension is installed on your local machine, it must be trusted. I mean, implicit trust strikes again.
Which is incredibly dangerous when you consider where developers are getting their extensions and their code packages in the first place.
Exactly. So we've established that local AI agents are blindly trusting the invisible files hidden in their workspaces. But that begs a much bigger question, right?
How are they getting there?
Right. How are those malicious files getting onto the developer's machine in the first place? And that takes us out of the local sandbox and into the global supply chain.
This is where things get really messy.
Yeah, because multiple security firms, so Wiz, Socket, Step Security, among others, they just sounded the alarm on a massive credential stealing campaign targeting SAP-related NPM packages.
The one they're calling the mini Shai-Hulud.
Yes, the mini Shai-Hulud. They are targeting JavaScript packages like CodeKey and AtCap.js/Slight.
Right. And when a developer innocently downloads one of these compromised packages to, build their application, they are inadvertently bringing a highly sophisticated credential vacuum right into their network.
Okay, walk us through the mechanism here. How does downloading what looks like a standard package trigger this massive compromise?
Well, the attackers introduced a new package.json pre-install hook into the compromised releases.
Okay.
So before the package even finishes installing, this hook runs a file named setup.mjs, which basically acts as a runtime bootstrapper.
What does it bootstrap exactly?
It reaches out to GitHub releases, downloads a platform-specific zip file containing the Bun JavaScript runtime, extracts it, and immediately executes a credential stealer called execution.js.
Wow, that's fast.
And it is brutal in its efficiency. It blindly follows HTTP redirects, and if it detects a Windows environment, it uses PowerShell with the -execution policy bypass flag.
So it just ignores local security prompts completely.
Completely. It ensures it runs without any interference.
And the sheer scale of the data they are harvesting is staggering.
Huh.
I mean, they are pulling local developer credentials, GitHub and NPM tokens, GitHub Actions secrets, and even cloud secrets across AWS, Azure, GCP, and Kubernetes.
They are taking everything.
Literally everything. But how are they getting all of this out of the network without setting off massive data exfiltration alarms?
Well, because they don't just steal the data in plain text. They treat it like a highly secure bank transfer.
Interesting.
Yeah, they lock all your stolen secrets using military-grade encryption, specifically AES 25x GCM.
Okay, that's heavy duty.
It is. And then, to make sure absolutely no one else can read it, they take the key to that encryption and lock it inside an RSA 40096 envelope.
Wow.
The public key used for this is embedded right in the payload, and it's actually linked to a known threat actor group called Team PCP.
So the only people holding the private key, the crowbar to open that envelope, are the attackers themselves.
Yes. So even if your security team intercepts the data as it's leaving your network, you can't see what they took. You just know something left.
That is incredibly frustrating for defenders.
Very. And they exfiltrate this encrypted data back to GitHub. They actually create public repositories on the victim's own account with the description, "A mini Shai-Hulud has appeared."
Unbelievable.
Yeah, and at the time of these reports, there were over 1,100 of these newly created repositories.
Over 1,000. And, just to document the payload's factual behavior here, to keep things completely impartial, the reports note that the malware specifically checks the system's locale.
Right. Yeah. That's an interesting detail. If it detects a Russian locale system, the payload simply shuts down and does not execute.
Right, it just exits. Now, I want to pivot to how they managed to poison these official SAP packages in the first place. Because official enterprise packages don't just let anyone upload an update.
Definitely not.
This goes right back to our main theme. They exploited a critical configuration gap in NPM's OIDC trusted publisher setup for the AtCap.js/Slight package.
This is a vital technical detail for anyone managing repositories. So OIDC, or OpenID Connect, is a system that allows GitHub Actions to request a short-lived NPM token.
Instead of a permanent password.
Right. The benefit is that developers don't have to store long-lived, sensitive passwords in their repository.
It's sort of like a high-tech security badge system for a corporate building. But the scanner in this case had a fatal flaw. It approved any badge that simply belonged to the building, not just the authorized release managers who actually work on the main floor.
That analogy is spot on.
Right, because the configuration trusted any workflow within the repository instead of just the canonical release workflow on the main branch.
Exactly. So an attacker compromised an account that had basic access to the repository, and they simply pushed a modified workflow to a non-main branch.
And because of that configuration gap, The system implicitly trusted the workflow.
Yep. It granted them a valid OIDC token, and they used that token to publish the malicious packages without leaving standard provenance trails.
Wow. But the shocking part of this report is what the payload does after it gets in. Step Security highlighted an evolution in this malware that I think completely shifts the paradigm.
Oh, the AI persistence vector.
Yes. Once it infects a system, it commits itself into every accessible GitHub repository by injecting two specific files, a .claude/settings.json file and a .vscode/-tasks.json file.
If we connect this to the bigger picture, it abuses Claude Code's session start hook, and it sets VS Code to run the malware every time a folder is opened.
That is devious.
It really is. It makes it one of the very first supply chain attacks to explicitly target AI coding agent configurations as a vector for persistence and propagation.
Let's just pause and think about the irony of that for a second. I mean, we brought AI into our code bases to help us write more secure software, right?
Hey, to spot vulnerabilities.
Exactly, to act as a guard dog. And the attackers realized, hey, the developer trusts the AI implicitly. So if we infect the AI's blind spot, we infect the developer.
The guard dog has literally been turned into the Trojan horse.
Exactly. They know developers are relying on these tools, so they are turning the AI's own configuration files into the malware's hiding spot.
Which means, even if you clean your code base, if you don't realize your AI assistant is compromised, the malware just reinstalls itself the next time you ask the AI for help.
That is just a nightmare. Okay, so you lock down your local AI, you meticulously vet your NPM packages, you secure your supply chain.
You do everything right.
Right. But none of that matters if the foundational infrastructure hosting the final website has its front door completely removed. Let's talk about cPanel.
Oh, man. This is CVE 2026-4940. It is a CVSS 9.8 vulnerability affecting cPanel and Web Host Manager, or WHM.
The software powering like half the internet.
Exactly. It's the management software for a massive portion of the internet's websites. And this was classified as an unauthenticated authentication bypass.
Wait, I need to interrupt because cPanel's been around for decades. It is literally the backbone of the internet for millions of small and medium businesses.
Yeah, it's ubiquitous.
Are you telling me that in 2026, an attacker can bypass authentication on these servers without a password?
Yes. And Rapid7 discovered the technical mechanism here is surprisingly simple.
Simple how?
It involves a carriage return line feed, or CRLF, injection. So before authentication even occurs, the cPanel service daemon, called CPSRVD, writes a new session file to the disk to track the user's connection attempt.
Okay.
Well, attackers found that by injecting raw/r/n characters, so the carriage return and line feed characters, via a malicious basic authorization header, they could manipulate the system's tracking cookie.
Okay, wait, explain that mechanism. What does injecting a carriage return actually do to the server's logic?
Okay, think of a CRLF injection like slipping a fake end-of-page marker into a stack of legal documents and then immediately following it with your own forged contract.
Okay.
The server reads the carriage return, thinks the original authorization processing step is completely over, and it just blindly starts executing the next line of text you handed it.
Just because of a line break.
Yep. In this specific case, by manipulating that cookie formatting, they tricked the system into completely omitting the encryption process that is usually applied to an attacker-provided value.
It just skipped the encryption step entirely because it trusted the formatting of the header.
Exactly. And because the system subsequently writes the session file without sanitizing that data, the attacker can insert arbitrary properties directly into the file.
Oh, no.
They literally just injected the text user equals root into the unencrypted session file.
Just user equals root. That's it.
That's it. Then they trigger a reload of the session. The system reads the file, sees the unencrypted user equals root text, and because it implicitly trusts its own session files, it establishes full administrator-level access for the attacker.
Wow. Just writing user equals root in plain text. So what does this all mean for the scale of the exposure here? Because cPanel isn't just like a niche tool, it's everywhere.
The panic across the cybersecurity community was immediate. Benjamin Harris, the CEO of Watchtower Labs, he captured it perfectly.
What did he say?
He said that within hours of the advisory dropping, quote, nearly every major hosting provider on the planet had firewalled their own customers off their own product because the alternative was watching their entire customer base get owned in real time.
Oh my gosh, they had to lock their own customers out.
Companies had to literally block access to management ports just to stop the bleeding while patches were applied.
And the scale is terrifying. iSecurity identified over 2 million cPanel instances connected to the internet. 2 million.
And Hadrian's analysis pointed out why this is so catastrophic. Compromising cPanel isn't like hacking a single WordPress site.
Right.
WHM grants root administrative access to the actual underlying server. An attacker isn't just hitting one site, they can read every single customer hosting account on that server.
Which could be hundreds of sites.
Exactly. They can modify underlying databases, create backdoor SSH accounts, steal credentials, and even pivot laterally into internal corporate networks.
It's a total disaster.
Hmm.
So bringing all these reports together, I think the core through line of this briefing is incredibly clear.
Crystal clear.
The system's designed to make technology frictionless. So the headless CI/CD pipelines, auto-approving code environments, the OIDC token exchanges, streamlining package publishing, the seamless server administration of cPanel, these are exactly the places where friction needs to exist.
Absolutely.
Security requires explicit, verified trust. It simply cannot survive on implicit assumptions.
And to you, the listener, the practical application of this knowledge is urgent. Whether you are managing an enterprise-scale GitHub repository or just running a small business website on a shared cPanel hosting plan, you have to audit your automated tools today.
Don't wait.
Apply the cPanel update scripts immediately, or ensure your inbound traffic is firewalled on ports 2083, 2087, 2095, and 2096. Check your Cursor IDE configurations and definitely review your OIDC permissions. Do not rely on implicit trust.
Yeah, that is the big takeaway. Because if our automated security workflows and our highly advanced AI agents are now the primary targets of these incredibly sophisticated supply chain attacks, who or what is going to audit the auditors when the AI itself is compromised from the inside out?
It's a scary thought.
It really is. You know, we started this deep dive by talking about that smart door that just automatically unlocks for anyone holding a clipboard. Well, it turns out we didn't just install that door on our houses. We installed it on the servers that hold the entire digital world. Make sure you check your locks.